Okay, should I start?
Start.
All right, all right. So good afternoon, great people of free astroscience. My name is Miracle Chibuzor Marcel, and I will be teaching uh Andromeda Galaxy and the local group. Last time we talked about the introductory part of galaxies. So today I am going to delve deeper into it. So today we are going to be learning about Andromeda Galaxy and the local group. So from the table of content, I'm going to review on the theme some of the lessons we learned from the Hubble classification. The last time I lectured, I talked about the Hubble classification. Then I'll talk about the meaning of Andromeda Galaxy. So I'll talk about in relation with the Milky Way galaxy, the satellite galaxies. Then I'll talk about the distance to Andromeda Galaxy and the features of the Andromeda Galaxy. Then I'll talk about the Andromeda From my last lecture, I talked about the Hubble classification. So I said that Hubble in the 1920s, he observed several galaxies and came up with the Hubble classification, which looks like a tuning fork. So we call it the Hubble tuning fork. So in that classification, he came up with four. Okay, we have the elliptical galaxies, we have the spiral galaxies, and we have the bar spiral galaxies. During his time, he came up with only three, okay, but later on, other astronomers added the irregular galaxies. So that is what we have for now, the classification. So that will bring us to the Andromeda galaxies. So and the local group. So what is the Andromeda Galaxy? The Andromeda Galaxy is also known as Messier 31. Remember, Messier, Charles Messier, the astronomer that was interested in, observing comets. So he made some catalog so that he can distinguish nebulae from comets. So he was able to catalog Andromeda Galaxy as M31. So the Andromeda Galaxy is the closest spiral galaxy to our Milky Way. Okay, remember what I said? I said closest spiral galaxy. Okay, not the closest galaxy, because many people, when you ask them what is the closest galaxy to our Milky Way galaxy, they'll say it is Andromeda. But in fact, it is not Andromeda. We have other galaxies that are closer to us than the Andromeda galaxy. So, but the Andromeda galaxy is the closest spiral galaxy to us. And I'm going to explain that in a few moments. So it is located at about 2.5 million light years away from Earth. I'm going to elaborate on that in the future. So, so what is the closest galaxy to us? Now, in our Milky Way galaxy have some satellite galaxies, so call them dwarf galaxies, okay? So those are galaxies. They are actual galaxies. They have the definition of a galaxy, but they are dwarf galaxies. But for the fact they have the definition of a galaxy, we still regard them as galaxies. So you can actually count those ones as part of the galaxies that are closer to us than the Andromeda. So some of them are Canis Major dwarf galaxy, which is about 25,000 light years away. We have the Sagittarius dwarf spheroid galaxy, which is about 70,000 light years away. We have the large Magellanic Cloud and the small Magellanic Cloud at about 160 to 200,000 light years away from us. So we have several, if you counted them, they're up to 10 or 9 here. So we have several dwarf galaxies that are much closer to us than the Andromeda galaxy. So let me check my, just a moment. Okay, so I want to check if my if my computer is charging. All right, so here are some of the examples of these dwarf galaxies that I just mentioned. So you can see their positions. You can see the Sagittarius dwarf galaxy, the also Major galaxy, the small and the large magnetic cloud. So those galaxies are much closer to us than the Andromeda galaxy. So, but why did we say that the Andromeda galaxy is the closest galaxy to us? It is because it is closest spiral, because some of these galaxies are spirals. Some of them have no shape, they're irregular galaxies. So mostly irregular galaxies. So how far away is the Andromeda galaxy? The Andromeda galaxy is at a distance about 2.5 million light years away from Earth. To understand the magnitude of this distance, so we're going to use some things that we are familiar with to help us to visualize it. So for instance, the Earth-Sun distance or the Sun-Earth distance we call it one astronomical unit, okay? That distance is equivalent to about 150 million kilometers from Earth, okay? So, but let us reduce it. Let us reduce that one astronomical unit to 1 meter, okay? 1 meter. So if you do that, if you shrink the distance between the Andromeda galaxy to our Miracle galaxy, that should give you about 16,700 kilometers away. So that is roughly the distance from Nigeria to Canada, about 4 times from Nigeria to Canada. So even as we have shrunk it to that level, it is still far away. So so just want you to imagine how far away it is. Very far away, 2.5 million light years away from Earth. So assuming that you want to fly to Andromeda galaxy, with our normal commercial aircraft, okay? Normal aircraft move at a speed of about 900 kilometers per hour. If you move to Andromeda Galaxy in a normal commercial aircraft, that should take you about 2.8 trillion years to reach. 2.8 trillion years. I mean, 2 trillion 800 billion years. That's a lot of time. Remember, our universe is just 13.8 billion. So cannot compare trillion to billion. Even 0.8 that is attached to it is 800 billion. So it's insane distance. So what if you want to walk there? That's unspeakable. That's going to take about 500 trillion years to reach Andromeda galaxy. So, but we can still see it. We can still see it. So despite the distance, we can still see it with our eyes. Okay, if you have a good sight, you can still see the Andromeda galaxy. So why can we still see the Andromeda galaxy? It is because it is very big. It is very, very big. Andromeda galaxy is the biggest galaxy in the local group. So we can see it with our naked eyes in a very pitch dark sky. So look at this picture here. You can see the Milky Way galaxy. This is the plane of the Milky Way galaxy. Okay, everybody can see that from their country. So if you look towards this direction, you're going to see the Andromeda galaxy. You can see with your naked eye, but to have a better view, you can use the binoculars your or your telescope to see it very clearly. But left alone, if you have a good sight, you can still see it with the naked eye. So it is there because it is very big. So let's talk about the features of the Andromeda galaxy. Some features of the Andromeda galaxy. So um, when we were talking about the Milky Way galaxy, we said that the diameter from one end to the other is about 100,000 light years away. Okay, so now for Andromeda galaxy, the distance, the diameter is about 220,000 light years across. So this is like more than double the size of our Milky Way galaxy. More than double. That is insane. Okay, and it has about over a trillion stars, more than double the size and over a trillion stars. Remember, our Milky Way galaxy is about 400 billion stars. So, but Andromeda galaxy is over a trillion. So that is why it's even bright, because all of these stars are shining, so adding to the light. So it is the largest it is the largest galaxy in the local group with a mass of about 1.5 trillion solar masses. Just like our Milky Way galaxy, it is a barred spiral galaxy, and it has an apparent magnitude of about 3.5, which is which is within the the visibility of the naked eyes in a dark sky. So human beings can see it. So here's the picture of the Andromeda Galaxy. So you can see the Andromeda Galaxy, okay? But there are some features that you may not be able to see very well here. For instance, this is the Andromeda Galaxy in the infrared spectrum. So in the infrared spectrum, you can see the spiral. It has spiral, okay? It has spiral arms. But in this picture, this is the optical spectrum. You may not be able to see those spiral arms. So the Andromeda Galaxy has a well-defined spiral arms composed of stars, gas, and dust. These arms are regions of active star formation and contain bright, bright nebulae. Okay. Now it also have a central bulge. That's a central bulge. Show you the central bulge in the infrared spectrum. Okay, this contains a concentration of stars that are old. Okay, so suggesting a history of mergers with smaller galaxies. So it also has a halo, just like other galaxies. It has a halo. So Andromeda halo has an extensive stellar halo, which contains ancient stars and globular clusters that help astronomers trace evolutionary history. So look at this picture now. So it is an illustration that depicts the gaseous halo of the Andromeda Galaxy if it could be seen with the naked eye. So if you can see the halo of the Andromeda Galaxy, okay, that should be that big. Okay, so now here's the Milky Way, like I just showed you before. Yeah, I showed you before here. So the galactic halo should be around that big. That's what I just explained here. So just like our Milky Way galaxy, the Andromeda galaxy also has satellite galaxies, as you can see here. So we can count about four. Okay. So we have M32, M110, NGC 147, and NGC 185. So just like other galaxies and just like our Milky Way galaxy, it has a supermassive black hole at the core. So that supermassive black hole has a mass of about 140 million times the sun's mass. Okay, and that is way bigger than the central black hole of our Milky Way galaxy. Our Milky Way galaxy, black hole is about 4 million solar masses. Why? Andromeda is about 140 million. So that's a lot. That's a lot of mass. So can even divide it, it is very, very over that size. Now, many people you must have heard that the Milky Way, the Andromeda galaxy is on a collision course with our galaxy, our Milky Way galaxy. So which is about to happen in the next 4.5 billion years. And that is very true. So when we observe, how we know it is because when we observe the Andromeda galaxy, we see it approaching us. We see that the light coming from it is blue shifted. Okay, and what do I mean by blue shifted? Okay, in Doppler effect, okay, let me use Doppler effect as an example. Or police siren, when police siren is coming towards you, the pitch is higher frequency. When it is moving away from you, it is lower frequency. So that is for sound. But for light, it is the energy, the frequency, okay? So when light is approaching you, it is blue shifted. I mean higher energy than the source. Higher energy, okay? So not that the light might be blue. I am not saying the light is blue in color, but more energetic, so more energy, more frequency. Okay, I mean to be more contracted. Then when it is moving away, it is going to be redshifted. So this is an example of what I mean by that. So assuming you are observing a galaxy and it is blue redshifted, it's going to be red. Okay, this is the redshift of galaxies. When it is approaching you, it is blue shifted. So you can use that. So this was used in Valentine. So assuming your lover is your relationship is tearing apart, your lover is leaving you, so this redshift. If your Lover is approaching, that's bullshit. So you can use the Valentine scenario to relationship scenario to or to understand what I'm talking about. So when we observe the Andromeda galaxy, we see that it is coming towards us. So that is why we know that it is coming towards us. And it's coming towards us at a speed of about 110 kilometers per second. 110 million kilometers per second. That's a lot of speed. So the Andromeda galaxy collision, the Andromeda Milky Way is a slow collision. I mean, astronomical slow collision. So it's going to take multiple billion years. And here is the breakdown. So presently, okay, Andromeda in which is about 2.5 million light years away, it is moving towards us at a speed of about 110 kilometers per second. Okay, so the Milky Way and the Andromeda galaxy will continue to evolve. They are still forming their stars. They are just doing their normal thing. Okay, so as if nothing is going to happen. Okay, so and also interacting with the satellite galaxies. But at 4.5 billion years from now, the Milky Way and Andromeda we have their first close pass. So it's like a porous system, like porous. Something has a hole, so they're gonna just pass through each other. Okay, but the gravitational force is going to distort their beautiful spiral arms. Going to disrupt their beautiful spiral arms and turn it into a very long tidal tail. But the stars within those galaxies are not going to collide because the distances between stars. Okay. However, the giant molecular cloud, the gas cloud, that the pillars of creation stuff, okay, they're going to collide because they're big. They're astronomically big, so they're going to collide. And when they collide, they're going to compress and it's going to trigger star formation, like intense star formation. That is how we know galaxies are colliding when we look at others. So now, when they pass through each other, they're going to just keep moving, but the gravity is going to put them back. So for the second encounter, that's about 5 billion years to about 6 billion years from now. So they're going to start merging. The supermassive black hole is going to merge, and the collision will strip both galaxies of that beautiful spiral structure, like I've said before. Now, when that happens, about 7 billion years, they're going to finally merge into one single galaxy called the Milkyometer. We call it the Milkyometer galaxy. That is Milky Way and Andromeda coming together to become Milkyometer. So at that, a new galaxy is going to be formed, which we believe is going to be elliptical galaxy, but that is how most elliptical galaxies are formed. They are formed from galaxy mergers. So star formation will slow down as available gas is used up or ejected into the intergalactic space. So how about the sun? So if the sun is still around, which I doubt, but if the solar system is still around, we may be in new position in the new galaxy. Okay, so here is a simulation of everything I've just described. So everything I've just described. So this is just our epoch now. This is our Milky Way galaxy doing its own thing, interacting with the satellite galaxies and forming stars. So as the time approaches 4.5 billion years, so they're going to start coming closer. The distance is going to be much, much closer. So they're going to come, even the speed is going to increase because of the gravitational influence. So they're going to just collide. They're going to pass through each other. So all the things I've just explained is going to be demonstrated here right now. So just watch out. So they collide, they pass, the gravity is going to pull them back. Gravity is going to pull them back. So collide again, collided. At this point, even the supermassive black hole is going to merge. So, and that becomes an elliptical galaxy. And so it's looking like that color, like reddish color stuff. It's not looking that bluish bright. So here is the triangular galaxy. It might still collide. It might still merge. Okay, it might still merge with this one. I believe it might still merge in the future, but we're not focusing on that. So that is about 7 billion years from now. So we have the Milkyometer. This is the Milkyometer. So what will happen to our solar system? What will happen to our Earth uh, and our solar system? So now, despite the size of both galaxies, the individual stars in those galaxies are separated by vast distances. Okay, so making direct star collision extremely rare. So stars are likely not going to collide. Okay, so the sky will drastically change. Okay, as the Andromeda is approaching us. Okay, the distance is getting smaller and smaller. Okay, the Andromeda galaxy is going to become larger. Okay, and brighter. It's going to become larger and brighter over millions of years. So by the time of the merger, the sun, remember when we talk about the sun, we say in the next 4.5 billion years to 5.5 billion years, the sun is going to move away from the main sequence stage. So at that same time, the Milky Way and the Andromeda are going to collide. So the two things are going to happen. So um so at that stage, the sun will be a red giant. Okay, maybe probably by that time, the future humans must have moved to another world, so another galaxy to another planet. Maybe, who knows? So, so simulations suggest that the solar system might be ejected to a different region of the new galaxy due to gravitational interaction. So, yeah, although the stars are not going to have a direct contact, okay, they're not going to collide, less likely, but gravitational interactions are imminent, so it's likely they're going to be moved to a new location in the new galaxy, the Milky. So here's the picture. This is an artistic picture of how the event as the Andromeda galaxy is approaching us. So here's the Milky Way. So as it's coming closer to us, so this is like in the next 3.7 billion years. So it's going to get really, really brighter and bigger. So the future civilization are going to see it this way. So that is, I mean, billions of years from now. We are long dead by then. So now, like I've just explained about the galactic collision of the Milky Way and the Andromeda galaxy, and the question is, does other galaxies collide? Have we have evidence of other galaxies collide? And the answer is yes, we have evidence, plenty of evidence of other galactic collisions. And I'm going to share a few of them. So for instance, the Antenna galaxy, these are two galaxies. Can I see the tray? They have collided. Okay, the antenna galaxies are two galaxies, NGC 4038 and NGC 4039. So there are two spiral galaxies in a collision that began over 100 million years ago. So we have the Mice galaxy. The Mice galaxy, they have likely passed through each other and will continue to interact, potentially merging over hundreds of millions of years ago. So here's the Mice galaxy. So we have other galaxies. We have the NGC 4567 and NGC 4568. So there are two on-board spiral galaxies, just beginning to collide. Okay, so we have a lot of evidence of these galaxies. And here we have these very very distinguished galaxies. These are a group of 5 galaxies, but 4 are already interacting. They are going to collide. Okay, we call it the Stephen Quintet galaxy. So the local group. How about the local group? The local group is a gravitational band collection of more than 80 galaxies. Okay, which includes the Milky Way galaxy, the Andromeda galaxy, and the Triangulum galaxy, and numerous dwarf galaxies. So if you look at this picture, you can see the Andromeda galaxy here. You can see the Milky Way galaxy here, surrounded by some dwarf galaxies. And so even the Andromeda galaxy is also surrounded by some dwarf galaxies. Then we have the Triangulum galaxies. Then we also have some other dwarf galaxies scattered around. Okay, so about 80 galaxies in this region. So about 80 galaxies in this region. So they span about 10 million light years across. But like I said, most of the galaxies in the little group are dwarf galaxies. So here's the picture, um, you know, of the galaxies and their sizes. So like I said before, the Andromeda galaxy that we just studied is the biggest in the local group. So we have followed by the Milky Way galaxy, followed by the Triangulum galaxy, and gets smaller as we move on. So how about in gravitational interactions in the local group? Okay, so like we said before, there's a lot of activities going on in the local group, a lot of measuring a lot of gravitational interactions. For instance, we know that we have just seen that the Andromeda galaxy and the Milky Way are going to collide in the next 4.5 billion years from now. So, and eventually, so we have a Milky-ometer. Eventually, the triangulum galaxy is going to merge with the Milky-ometer. Okay. So we have a lot of gravitational interactions. Even the satellite galaxies at the moment are being cannibalized, that they are being swallowed in by the Milky Way and Andromeda. So as we can see from the Sagittarius dwarf galaxy and the Magellanic Cloud, they're just eating them up. So there's a lot of gravitational interactions going on. So that is the end of my lecture. Thank you very much. Yeah, I'm done.